Good day, guys. We want to see one more problem on analytical part of circle geometry. So, in this question, we have two circles that meet internally at the point B with coordinate 6, -1. And one thing we must pick from here is that A is the center of the larger circle, while O is the center of the smaller circle. And they've gone on to give us the equation of the larger circle as x squared plus y squared minus 6x plus 8y plus 7 equal to 0. So the first part says we need the radius as well as the coordinate of the center of the larger circle. So you can only get that from the equation of the larger circle. So let's move on. The equation of the larger circle is x squared plus y squared minus 6x plus 8y plus 7 equal to 0. So to go through this, to help us get the center, we need to start by appreciating the fact that these are two quadratics. We group them together, complete the square until it will take us to a format that looks like this, where we can get the coordinate of the center and the radius of the larger circle. So let's start by grouping our quadratics together. So I'll get x squared minus 6x. This is my first quadratic. Then I get y squared plus 8y. This is my second quadratic. Then this constant, I'm taking it to the right hand side. So in that way, I can now concentrate on the procedure of completing the square. So to complete the square, we always copy the first two items exactly the way they are. Then we take half the coefficient, square it, then we add on both sides. So for the first quadratic, I have x squared minus 6x. So the coefficient of x is actually the number written before x, and that is a -6. If you miss the negative, you're already in trouble. It's a -6. So if we take a half of -6, that will give us a -3. So I'm going to square -3. I add it on the left, then I go to the right, I do the same thing. I also add -3 squared. So that is what we do. Then we also repeat that process for the second quadratic in terms of y. So capture our y squared plus 8y, then plus the coefficient of y is 8, half of 8 is 4. If you square 4, you add it to the left, and you also add it to the right. So in this way, we have succeeded to complete the square of each quadratic. So the next thing now is to write that complete square for each quadratic. So if I go for the first quadratic, to get the complete square, I only look at the two items carrying a square. I bring them down. So I'll write my x and my -3. That is my complete square. I do the same thing for the other quadratic in terms of y. I only bring down the two items carrying the squares. So I'll get my y plus my 4. So I've seen the complete square. Then on the right, I just need to use all of this on a calculator. So this is 9, -3 squares is 9. This one, 4 squares is 16. 16 plus 9, that gives us 25. 25 minus 7 should give us 18. So this is how my equation of the larger circle will look like in another format. So in this format, if I match it to the standard formula for the equation of a circle, which is always given to Maths level 4 student as formula number 4 on their formula sheet, it means I now know the coordinate of the center because they match there, and that is my radius. So if I'm looking at that, I will say if my r square is equal to 18, then my radius will be the square root of 18. If you want to leave it like that, it's fine. If you want to use your calculator to see it as 3√2, that is still okay. And you must know that this radius of the larger circle is the distance AB. Now, if I go to the coordinate of the center, all I need to do is equate this to 0, solve for x, I equate this to 0, solve for y. So I'm saying if x minus 3 is equal to 0, this means that x will be equal to 3, and if y plus 4 is equal to 0, this means that y will be equal to negative 4, and this therefore tells me that the coordinate of the center of the larger circle is 3 and a negative 4. So guys, for the first part of the question, we are done. We have succeeded to get the radius of the larger circle as r being root 18 or 3 root 2, and we've also succeeded to get the coordinate of the center, that's the coordinate of A, as 3 and negative 4, after we succeeded to complete the square of that general format of this equation of the circle to bring it to this other format. So, if we are all fine, we can then switch over to the B part. The B part requires us now to determine the equation of the smaller circle in the form x minus a ordered square plus y minus b ordered square is equal to 0. So, that therefore means we need to know the coordinate of the center of the smaller circle as well as the radius of the smaller circle. So the radius of the smaller circle, I want to start with that one. If I call it rs, that is just the distance OB or the distance OA. And looking at our diagram, O is the center of the smaller circle and AB is the diameter of the smaller circle. So that therefore means OA and OB are just a half of AB. So that is what we see, and we have succeeded to calculate AB already, which is 3 root 2. So it means the radius of the smaller circle is just 3 root 2 over 2. So that part is very simple to get. If you can interpret your diagram very well, you will see that OA is a half of AB. Then we can now look at the coordinate of the center of the smaller circle. That means we need the coordinate of O, and knowing that AB is the diameter of the smaller circle, that therefore makes things very simple because O is the center and automatically it is the midpoint. So if I need the coordinate of O, I simply use the formula for midpoint of 2 points, which for math level 4 students, this is formula number 5 on your formula sheet. So I use that with the coordinate of A and B to help me out. The coordinate of A, we've just calculated it to the 3 negative 4. That of B was given in the question. So this will take us to to 3, okay, 3 plus 6 over 2. Then the y coordinate will be negative 4 plus negative 1 over 2. So if you simplify that, you get a 9 over 2 for the x coordinate and a negative 5 over 2 for the y coordinate. So which means for the smaller circle, we have succeeded to get the radius, and we have also succeeded to get the coordinate of the center of the smaller circle. So writing the equation in this format becomes very simple. Therefore, I'll just take x minus 9 over 2, or this square, plus y minus 5 over 2, or this square is equal to the radius. We've got 3 root 2 over 2, or that square. So I guess with this, we are as good as done. The only thing I want to do now is to convert the two negatives to become a positive, because we have arrived at the format that the question is interested in. So there is no need for further simplification here. So this one, if you want, you copy it exactly the way you see it. You've written it exactly in the format that is required. So guys, I guess that is all for what I puzzled for you. Thank you very much.